So good afternoon, everyone. I welcome you to this wonderful session. Of course, this is the Mentor Hambio Kliman. Today we shall be looking at a very interesting question and tutorial sheet in mathematics from Eden University. Now, this particular tutorial sheet is under set theory. We are going to answer as many questions in mathematics as we can, okay, for natural sciences. And of course, the questions were really very interesting, so make sure you really pay attention to how these questions will be solved. The first question is actually saying, given that U is equal to, so they've given you this particular set, okay, that is the set that has been given. And then they say, is the universal set. And then they say X is a set of even numbers in U. Okay, so even numbers in U. So what are even numbers? Of course, even numbers are simply numbers that are divisible by 2. So we are going to recognize even numbers from this universal set. So we're going to say X is going to be a set which is going to be like this. Okay, so our X is going to start from, we've got -2 as an even number. Okay, sorry, let me just reduce on the pen. So this is going to be X. So our X is going to be a set which is going to start from your -2. -2 is an even number. And of course, 0, please don't forget, 0 is also even. Okay. And then of course, it's going to go to 2, then 4, and then 6, and then 8, and then 10, and then 12. Okay. 12, and then 14. Okay, so from 14 it will go 16. We're going to have 18. Then we're also going to have 20. From 20 we are going to have 22. From 22 we are going to have 24. 24 we are going to have 26. Okay, 26 we are going to have 28. 28 we are going to have 30. All these numbers are divisible by 2. We go to the next one. They're saying Y is a set of prime numbers. Okay, numbers divisible by 1 and itself. So we're going to list set Y. Set Y is going to be a set which is going to start from 2 itself. So you're going to put a 2 there, and then we're going to put a 3. These are just prime numbers. So our 3 is going to be there. We are also going to put a 5. Then we'll also put a 7. Then we'll put 11. And then we're going to put 13. Okay, 13, what else can we put? We can put 17. What else? 17. 18, 18. There's a number that can go there. We can put 19. From 19, we can put 23. From 23, what else can we put? Let me see, 23, 24, something can go there. 25, something can go there. 26, something can go there. 27, possibly something can go there. Okay. 27, 3 can go there. 28, something can go there. 2 can go there. 29. Okay, so 29 is a value which you are going to get. The rest of the numbers, something is going to get in there. Okay, so prime numbers are simply numbers divisible by 1 and itself. 1 and the number you are defining. Okay, we go to the next one. They're saying Z is simply a set of whole numbers. So Z is going to be long. So it's going to be this particular set. So Z is going to be a set which is going to move, because the whole number starts from 0. So just numbers from 0 all the way up to 30. So it's going to be 0, 1, 2, 3, 4, 5, 6, then all the way up to 30. These are all numbers. And then we go to B. They are saying B is equal to X is a member of all natural numbers and X must be less than 19. So natural numbers are simply numbers which are starting from 1. So we are going to have our set B, which is going to be listed in this particular order. So set B is going to start from 1, 2, and then it's going to go to, let me see, 3. Okay, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 15, they're saying it must be less than 19. 15, 16, 17, 18. So it's going to go up to 18, right? So set B is going to end on 18. We have it there. Now, they're saying, and then C is a set which is going to be a set of all integers starting from 2 less than x, then less than or equal to 17. So let's name set C. So C is going to start from 3, and then it's going to go 3, 4, 5, 6, 7, 8, 9, 10, 11, then 12, okay, 12, 13, 14, 15, 16. Then because there is less than or equal to here, so it's gonna go up to 17. So I'm going to put your 17 here. Okay, this is how it's going to be. Now, this particular question was just too long in terms of you just distributing the numbers or just listing your given sets. The rest of the things are just simple. So I'll be able to solve the first one, and then I'll be able to explain the rest, how you're going to solve them. So the first one is an operation. They're saying we solve, so they've given you x, okay, they've given you x minus b, and then they are saying this is going to be b complement. Then there's an intersection y minus z complement. Okay, sorry, the complement is actually inside. Okay, so this is z complement. How exactly do you solve this particular set? So to solve this particular set, it is actually very, very simple. The first thing that you are going to do, okay, the first thing that you are supposed to, okay, to do. So basically for this one, I'll be able to explain just what you're able to do because I don't really want to go deep into solving these particular operations. Okay, this is just too long but too simple. Let me show you how you do it. You have seen whatever is inside here, right? So inside you have your x minus b. Now what does x minus b mean? X minus b under sets simply means all the members that are in x that are not in b. Okay, members, so you're going to say members in x not in set b. Okay, so you are going to list all the members that are in set x which are not in b. When you list those members, after you list those members, you now find the complement. In other words, the members that you are going to find, you just have to remove them, then collect whatever is going to remain in the universal set. So you are going to remove these members you're going to have, and then collect whatever is going to remain in the universal set. So let's say what you're going to remain with in the universal set is A. Then you intersect it with, now we work out this part. So what does this part mean? You have your y minus z complement, right? What does it mean? You are going to, this simply means collect z complement. So you are going to get all the members that are in set z, these members that are in set z. You are going to remove them, then collect whatever is going to remain in the universal set. Okay? Whatever is going to remain in the universal set, you're going to say y minus whatever is going to remain in the universe set where you remove set z. Okay, so you're going to say whatever remains in the universal set. Now, what does this mean? There's something that I'd mentioned here. This simply means all the members in Y which are not in that set, okay, in that set you remained with after you removed the set Z. Okay, whatever you're going to have here, all the members in set Y which are not here, okay, then whatever you're going to remain with, let's say that is B, you are going to find its intersection. That is what they mean, okay, by doing this particular set. It's actually very simple, okay, so it's very simple, except the whole numbers are just too long and the figures are just too big. So the explanation is actually very simple. You go to the second one. How do you go about the second one? They've given you x complement intersection B, and then they say complement, then they say intersection B intersection Y. So how do you go about this? It's very simple. Work out whatever is in the brackets. So you will get whatever is in here. So you're going to say x complement intersection B. How do you find this particular one? How do you find this? X complement, what does it mean? Complement means outside of. So you are going to collect all the members that are in set X. You are going to remove them, then collect whatever remains in the universal set. Right? You remove all the X values, then whatever you remain within the universal set is going to be your X complement. Then you intersect those values with B. Okay? Let's say when we intersect those values with B, we are going to remain with A. So you are going to A, you are going to get your A and then complement. Now, those values that you are going to find, you find their complement. You also remove them. Then you collect whatever remains in the universal set. That becomes your set. Okay? So let's say the set that remains is called your A prime. Okay? I'm just giving examples here. You're supposed to have values. Now, these values that you're going to remain with after you remove A complement, you intersect them with B intersection Y. So B intersection Y, what are you going to get? Let's say the set you're going to get is B. Then you find the value of this. So it must be numbers. I'm putting letters so that you are able to get the explanation. Okay? So the whole sets were just too long. The numbers were too long, but if really we had so much time, we were able to find this with easiness. Okay, let me be able to do the last one so that people don't really get confused. How about the last one? How do you simplify it? Okay, how do you simplify the last one? To simplify the last one is actually very simple, because you have X intersection B, right? And then they say intersection B there, intersection Y. Then they say complement, and then they say complement. Now, here what you are supposed to do is actually very simple, because this complement is affecting everything. Now, remember, you are supposed to know set operations, set algebra. Okay, if you haven't mastered set algebra, make sure you inbox me on this number plus 26034764046. Okay, so make sure you inbox there. If you want to register for tuitions at Etsy Learning Academy, make sure you also inbox on that particular number that I have given on the screen. We got to this particular question. Now, this question is also very simple. You just need to distribute the complement everywhere. So this complement exposed to X is going to have, you're going to remain with X complement. Okay, complement exposed to the intersection remains the union set. Complement exposed to B becomes B complement. Okay, so you're going to have this. Then complement exposed to the intersection, which is this one, becomes the union set. Complement exposed to B becomes B complement. Then complement exposed to the intersection becomes the union set. Complement exposed to Y. Okay, so let me see this. Okay, so this complement is basically affecting everything in this set, so it will just cancel out. So this is going to remain just like this. This is going to remain like this. And this is the set that you're going to have, right? So how do you find this particular one there? You have X complement union B complement. So X complement, remove the values of set X, get whatever remains in the union set, put it here. Let's say what you're going to get is C. Union B complement, get the values that are in set B, remove them. Whatever is going to remain in the union set is what you put here. Let's say you're going to remain with Y. Then you find the union. Whatever values you're going to get is your answer. So basically that is how you solve this particular question. Okay? That is how you solve this particular question. So I'll need to clear the board so that I may have more space to answer the remaining questions. Okay? The remaining question is very important. Now, we have been given question 2. Okay, let's see what question 2 is simply saying. So question 2 is a very interesting question. So question 2, what is it saying? It's saying, given that A and B are disjoint sets, simplify A complement union B complement. Now, what are disjoint sets? Disjoint sets are simply sets that have nothing in common. So when we say this is a disjoint set, those two sets have nothing in common. So you are going to have two sets. I'm solving this particular question. So you're going to have two sets. Set A. So because it's a disjoint set, the set is going to be here. They have nothing in common, right? Now they are saying that we simplify them. So you equate them to A complement union B complement, like that, right? So disjoint sets are sets which have nothing in common. They basically have nothing in common. Then from here, remember that from De Morgan's law, we know that A complement union B complement is actually equal to A intersection B complement. Now, because this and this are equal, it simply means that where there is this guy here, you can even replace with this, because this equal sign is saying whatever is here and whatever is here are equal, right? So this simply means that if we have set A and set B not having anything in common, this is just the same as A intersection B complement. Now let's try to find whatever is inside. A intersection B, because the two are not intersecting, they are disjoint sets. So whatever you're going to remain with is simply the empty set. There is nothing there, nothing remaining. So now because you have the empty set, this is the same as set A, set B is equal to, open bracket, the empty set complement. Now what is complement of the empty set? What is complement of the empty set? Complement of the empty set is simply the union set. Okay? The union set. So when they say simplify A complement union B complement, using this particular statement, your answer is simply the universal set. Okay? Your answer is simply the universal set. Hope you are getting the concepts and how the concepts are simply coming out. It's very important that you'll be able to understand this. I'll be able to wrap the board so that we can answer question 3 from here. So basically we are going to solve up to question 4. Then we continue from there. We go to question 3. Question 3 is simply saying, given that X and Y are subsets of the universal set E, show that, so this is what we have. They're saying we show that X intersection Y, the union of X intersection Y complement is simply equal to X. Now remember what I had taught. You need to factorize whatever is there. So X is common. We have X and X common there. So it's going to be X. The intersection and the intersection, they are common. So you factorize them. Then you're going to remain Y union Y complement. Now, Y union Y complement is equal to the universal. Remember set operations or algebras. So you're going to have X intersection the universal. What is X intersecting the universal? The answer is simply X, because whatever is in set X is also in the universal. So you are going to get X, and that is how you are getting X there. So you have actually proven. You have proven. Okay, let's try the second one. The second one, they're saying this is X union, open bracket, then X complement, then intersection Y. Then they say we prove that it is actually equal to X union Y. From here, what exactly are we supposed to do? It is actually very simple. Now, look at this. You are going to use a law that we already taught. It is called the distributive law. So you are going to distribute X, the union of X, the union of. So what is X, the union of multiplied by X? It's going to be X, the union of X complement. Okay? Then you find let's see. So from there, you're going to say intersection. Then you're going to say this X, the union of multiplied by Y. It will still be X, the union of Y. Okay? Now, what is this? I already taught you, because I already said that whenever you have Y, the union of Y complement, it is the universal set. So even here, whenever you have X, the union of X complement, you're going to have the universal set intersecting X, the union of Y. Now, what is the universal set intersecting X union of Y? Remember that the X union of Y is still in the universal set. So the set you will still remain with is simply X union Y. And you have proven henceforth. So you have showed. Okay? That is how you prove this particular question. We get to question 4, which is simply De Morgan's law. De Morgan's law. Okay? De Morgan's law. So, with De Morgan's law, it's actually very simple. Remember, De Morgan's law, they're just trying to tell you that whatsoever you can do on your right-hand side can also be done on your left-hand side. What does that imply? A very good example is what we have in the question, like the first one. We have A intersection B complement. Then they're saying, show that it is equal to A complement union B complement. Using De Morgan's law, it's actually very simple. And you'll be able to see how it's going to hold. Let's see how beautifully De Morgan's law can actually hold. Okay, so let's first of all get the sets that we have been given. So they're saying let E be a set of whole numbers less than 11. So let's name E. So E is going to be this set. So whole numbers are numbers that are going to start from 0 all the way to 10. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They should be less than 11. We have them. Then they're saying A is actually given. A is actually given. It is 0, 2, 4, 6, 8. B B, they're saying it's a set of prime numbers less than 9. What are prime numbers? Numbers that are simply divisible by 1 or itself. So it's gonna be starting from 2, 3, 5, 7. Okay, so because they're saying it should be less than 9, so it will just end at 7. It's very important to obey the instructions given in the set. Now, we have been given this question. So this question is actually saying we prove that A intersection B complement is equal to A complement the union of B complement. Now, this is how you prove De Morgan's law. So you are going to say left hand side. So left hand side. So on your left hand side, we are going to prove this. You work out that first. Okay? So we are going to start with whatever is inside. So what we have inside is A intersection B. What is A intersection B? A intersection B is going to be this particular set. So what is common in A and B? It's actually just 2. Now they are saying A intersection B complement. So what did I say about complement? Remember, in the first question I had mentioned, complement means outside of. In other words, just remove 2 and get whatever remains in the universal. So I'm going to remove 2. If I remove 2, what I'm going to remain with in the universal is going to be 0, 1, 3, 4, 5, 6, 7, 8, 9, 10. This is the set that I'm going to remain with. Okay? This is the set I'm going to remain with on my left hand side. Let me work out the right hand side so we can say right hand side. So right hand side, we have A complement union B complement. So let's work out A complement first. So A complement is going to be this set. So A complement, what is complement outside of? So remove all the members in A, and then whatever you're going to remain with in the universal is A complement. So I'm going to label all A. So this one is A, this 2 is A, this 4 is A, this 6 is A, this 8 is A. Okay, this 8 is A. Okay, hopefully I won't be able to wrap. Okay, this 8 is A. So now I'm going to get everything. So those that I've labeled, I won't get them because I've removed them. So I'm going to get everything I didn't label. So I'm going to remain with 1, 3, I also didn't label it. A5, I didn't label it. 7, I didn't label it. 9, I also didn't label it. 10, I also didn't label it. Okay? So basically, that is going to be my set A. I'm also going to do the same for B complement. B complement is me removing all the B members. Then whatever remains in the universal, that becomes my B complement. So I'm going to line them like this. So this and this out, this and this out, this and this is out, 7 and this 7 is out. So all those that I've lined, I won't be able to put them because they are actually not part. So this 0, I'll get it. The 1, I'll get it. The 4, I'll get it. The 6, I will get it. The 8, I will get it. The 9 and the 10, I will get. Now we find A complement union C complement. Okay? So we combine all the sets. So we are going to have 0, comma, 1, comma, 3, comma, 4, comma, 5, comma, 6, comma, 7, comma, 8, comma, 9, comma, 10. Now, look at this particular set that we have found. Look at the set that we have found. This set that we have found is the same as this one. Okay? They are both the same. This tells you that your right-hand side and your left-hand side, your left-hand side and your right-hand side are actually equal. And this is how you prove De Morgan's law. You can use the same concept to prove this one. So make sure you solve this particular question. Make sure you send it on this number plus 2603477664046, and I'll be able to respond to you. Make sure you subscribe to this YouTube channel, hit the like button, and also don't forget to share to others. We shall continue in our next session from question 5, where I'll be able to show you just how to be able to describe the shaded region. This is the mentor Hampio Kliman from HC Learning Academy. Thank you so much.